The next change we're going to make is going to require us to take a deeper look into the Unity physics system. Right now, we can jump unlimited numbers of times while we're flying around in the air. There's nothing really stopping us from just flying indefinitely. Now, I want to change that. That's more like a swimming mechanic. I want it to be so that we can only jump when we're on the ground, or when we've decided that we want to let the player jump. Maybe it's off of a wall, maybe there's a double jump, but for now, only when they're landed on the ground, not this weird state where I can just keep jumping indefinitely. To do that, we're going to need to figure out when the player is on the ground. Let's stop playing and let's go to the scene view real quick. So here I am at my scene view and I've got my alien selected. I'm going to double click on him and then zoom out just enough so that I can see the ground. Now, when I play my game and I let my character fall down, let's see what happens. I'm going to take the game view. I'll drag it down here to the bottom so it's kind of out of the way. Press play and watch as the player falls down. So he falls down and he kind of lands there, and I've got him right above the actual ground. And I need to determine how to tell if he's kind of on the ground, or I need to find a way to tell if he's on the ground. And there are a few different options for this. The way that works the best, though, the thing that I've found to be the most useful, is to do what we call ray casting, which means that we'll do a little check. We'll add essentially a little laser right down here at the bottom of this character and shoot it down and see if there's ground underneath him or if there's not ground underneath him. And if there is ground underneath him, if he's like very close to the ground, then we'll allow him to jump. If there isn't, then we won't allow him to jump. Now, to see this, or to get this working, I like to visualize it first. So I like to open up let's stop playing, open up my player script and add in some code to draw some cool gizmos so that I can see what I'm doing and kind of understand it quite a bit better. To do that, we're going to find our start method, and I'm actually just going to delete this. First, we'll take lines 11 through 15 and just hit delete because we haven't needed our start method and it's just kind of sitting there taking up 5 lines and getting in the way. So I'm going to delete them. My code should now look like this. I've just got my fields up top, my floats, my 3 floats, and then I've got my update method and then my closing braces. Make sure that everything matches before you start. And then right here on line 11, let's add an OnDrawGizmos. Now notice that I didn't capitalize it. That's because I know it's going to autocomplete, and I'm just going to hit enter and it's going to capitalize for me. So it automatically created an OnDrawGizmos. It's got the private void part right at the beginning and the parentheses. I don't actually need this private keyword, so I'm just going to double click on it and hit delete twice just to get rid of it. The void method doesn't have it. OnDrawGizmos doesn't have it. It doesn't need to have it either. The reason for that is that private is the default. It's like adding a special decoration to say that it's already the thing that it is. So we don't need the private keyword there. It's already private by default. The alternative is public, and we don't need this to be public. We'll talk a lot more about public and private later once we get into some scenarios where it actually makes sense. In our OnDrawGizmos method, we have the ability to draw gizmos on the screen or in the scene view. Now, if you're forgetting what those are, don't worry, we'll come back into Unity and take a look. Remember this little world that toggles all the gizmos on and off? That's that. These little icons, the colliders, and other things. This is going to be our own custom one. So let's go back to the player. Let's draw a simple line first. We'll say gizmos.drawLine, and we're going to draw it from vector 3.0 to vector 3.1. And we'll add the semicolon to the end. Let's go back into Unity and see what that does. We should expect to see a line right around the center of our world. There we go. Going from 0, 0, 0 to 1, 1, 1. So this is now actually in 3D too. If I go into the 3D view, you'll see that it's actually moving kind of over there backwards a little bit. If we go back to 2D though, it looks pretty flat. So this draws a line from one point to another point. What I want to do is draw a line from the feet of my character just downward a little bit so I can see where I'm checking for the ground. To do that, we'll go back to our player and we need to figure out where the feet of our player are. To get the feet of our player, we're actually going to use the sprite renderer component. Remember, that's the component right here that's drawing our sprite. This thing knows where the bottom of the sprite is, so we can use that value or use the sprite renderer to get that value and then pass it into our gizmo system. So let's go back into the code And the first thing I want to do is calculate where the bottom of our character is. And to do that, we're going to need to use the sprite renderer component. Remember how we got a component before on line 21 using the getComponent method? We're going to do the same thing here on line 13. We're going to add in a new line for our line 13. And we're going to say sprite renderer. And let's call this sprite renderer with a lowercase s. Notice the casing here. We've got an uppercase sprite renderer and a lowercase sprite renderer. The uppercase one is telling us that this is the definition or the type, the class definition, the sprite renderer type. We're going to say that whatever comes after this is going to be a sprite renderer. And then we're going to name it the exact same thing, but it can't have the same casing. We want to have a lowercase casing, or what we call Pascal case. So it starts with a lowercase s, and then we add in the capital R there so that it's easier to read. I mean, if we did it like this, sprite renderer, it would just be harder to read. That's why we use Pascal case, or camel case, not Pascal case. And it's much easier to read. This is Pascal case with capital S. This is camel case with the lowercase s. That's the difference between the two of them. All right, so sprite renderer equals, and then look at that. It already knows what I want. I'm just going to hit tab and let it fill it in. Get component sprite renderer. So that's going to get our renderer. And the renderer has a couple of unique or interesting fields on it. The one that we care about right now is the bounds. So we can get the bounds of the sprite renderer to tell us where the top, the bottom, the left, and the right are. So let's go back into our code, and we'll do that by saying, let's actually keep this off as a y value. So we'll say float bottom y equals, and we'll use the sprite renderer dot bounds dot extents dot y. Now let's use this bottom in this position in our draw line. To do that, let's actually create a vector2. We'll say vector2 origin, and we'll make it equal to a new vector2, and we're going to use our character's position. So we'll say transform dot position dot x, and then for the y we'll use transform dot position dot y. But we're going to subtract out that bottom y, or the extents. So we'll say minus bottom y. Then we'll add a semicolon here. And then on our draw line code, we'll change it from going to 0, or starting at 0, to starting at origin. And for our second value here, after the comma, I'm just moving around using the arrows. By the way, if you use control in the arrows, you can actually bounce around word by word. Hold down shift, and you can bounce over here and select the word. So I'm going to select that vector 3.1 and replace it with origin plus. And now what I want to do is do a line that goes downward just a little bit. So I'm going to use a vector2.down times 0.1f, which is going to give me a downward vector that's 1/10 of a meter. Remember, vector2.down would be down 1 unit or 1 meter, times 0.01 is 1/10, so it's going to take us down 1/10 of a meter. So I should get a line going from the bottom of my character down 1/10 of a meter. Now, one last thing I want to do is make this line red. Let's do it right before we draw it. Let's go up ahead, up one line, add a line on 16, and say gizmos dot color equals color with a capital C dot red with a lowercase r. We'll save, get rid of that little star, jump back over to Unity, and let's see if we have a little red line pop out of our character once it finishes reloading. Here it goes, and look at that, we've got a little red line down there. So we haven't used this to do anything except for draw a red line, but watch when I move my character around. Oh, I accidentally added a child object there. Let's move this guy around, and look, we've got a red line following him around. So that's perfect. That's kind of what I wanted to see. So now what we want to do is make it so that when our character's red line is overlapping with the ground, we can jump. If it's not overlapping with the ground, we can't. By the way, I'm just clicking and dragging him, moving him around. Remember, that's W on the keyboard to get into move mode, or you can click the move tool right here. You could be on a different tool like the panning tool or the rotating tool or something else. Just go to the move tool with W and move him around. So far so good. We've got our character drawing the line to show us where he's checking to see if he's on the ground, and I think that's good for this lesson. So let's save, go into plastic SEM and say that we added a grounding gizmo. We'll talk about what grounding means in just a moment. Added grounding gizmo, and check in our changes.